All right, so today we're working with systems of equations, and I'm going to talk about specifically a system with 3 unknowns or more. I'm going to do 3 unknowns, but this actually works with 3, 4, 5, etc. So if you look at this system I've got right here, x plus 2y plus z equals 4, 7y plus 2z equals 3, and 4z equals 20. And if you look at my 2 and my z, you'll see why I put a cross through my z. One of the things I learned early on in math is little things like that, so I don't confuse a 2 and a z. I always write my t's like that, so I don't confuse those with my plus signs. So anyway, just things you need to make sure you're paying attention to as a math student that'll help you a bunch. Also notice I always line up my z's and my y's and my x's. Again, it helps you a bunch in math to do that. So this is what's called a triangular system. Okay? And when you're trying to solve a system with 3 or more variables, you always want to make it a triangular system. Now, this one already is. I'm going to show you in the next example how to get this. But let's say we've already come across it. It's already a triangular system. That's fantastic. So here's what we're going to do. We're going to take this bottom equation, right? And we're going to divide by 4 on both sides because it says 4z equals 20. So it's pretty simple. And what do we get? We get z equals 5. Cool. I'm going to put a box around that. That's a final answer. Now, I'm going to take this second equation and I'm going to say 7y plus 2z equals 3. And notice what I did there. Instead of putting the letter z, I put parentheses because I know z is equal to 5, so I'm going to put a 5 in there. All right, cool. Well, I know that 7y plus 10 equals 3. I'm going to subtract 10 from both sides. That's going to give me 7y equals negative 7. And if we divide by 7, we get y equals negative 1. Cool. All right. So now I know z is 5. I know y is negative 1. So now I'm going to take this first equation, right? So take this top equation here, and we're going to go and sub in x plus 2y plus z equals 4. Okay? So we're going to plug all of that in. And we know that y is negative 1 and z is 5. And so I'm going to go ahead and combine some like terms here. So that's negative 2. Plus 5, that's going to give me plus 3 equals 4. And if I subtract 3 from both sides, I get x equals 1. And so our final answer is boom, boom, boom. And most of the time, if you're in a math course, they're going to want your answer as a point. Okay? And so you're going to go x, comma, y, comma, z. Okay? Right, so x, comma, y, comma, z. Okay, so 1, negative 1, 5. Okay, so that's it. That's how we solve a triangular system. This method is called back substitution. Back substitution. Okay, to me, it is the only good way to solve a system with 3 or more variables, and it works every time. That is, solve your shortest equation, sub it into the next shortest one, sub those answers, and you just keep going whether you have 3, 4, 5, 6 variables. Okay, cool. Here's the problem with this method. It's great, except I'm going to give you this problem here. Okay, now, here's my issue. We got this system here. It is not triangular. You can't solve for a variable because you don't have, 4z equals 20. You don't have 2y equals 8. You have 3 variables in every equation. So here's what we're going to do. We're going to use the elimination method. So what I'm going to do is I'm going to number these equations. Okay, so I'm going to number them 1, 2, 3. Okay. And all 3 of these have 3 variables. Okay, all 3 of these have 3 variables. Okay, we need to create 2 equations with 2 variables. Oops, got a mess here because I'm writing on an old crummy wooden cabinet with a lot of finish missing. The pen caught on something and tore the paper. All right, so we need to create some equations with two variables, and the way we're going to do that is with the elimination method. Now, it doesn't matter which variable you get rid of, but you have to pick one. So for me, I'm going to get rid of x. Okay, I'm going to get rid of x. So here's what I'm going to do. I'm going to take this first equation. I'm going to take this first equation, and I'm going to multiply it by 2. So take this equation here, multiply everything by 2, by negative 2, negative 2. So I'm going to get negative 2x minus 2y minus 2z equals negative 2. Okay, so everything by negative 2. And then I'm going to take this second equation, and I'm going to copy it down. And so I'm going to get 2x minus y plus 2z equals negative 4. Cool. Now, here's what happens. These go away, and these go away. Okay? And that's not really supposed to happen. That's not what I'm trying to show you. It's just absolute happenstance. And when that happens, and let me go back here. So we got 3 variables, 2 variables. And if you look at the last example, we also need an equation with 1 variable. Okay? Cool. I just created that by total happenstance because the x's and the z's both canceled. Yay! What do I end up with? I end up with negative 2y minus y is negative 3y, okay? And that's going to be equal to negative 6, okay? So I created that by pure happenstance, okay? So let's try something different then, okay? So let's try something different. Let's try to get rid of y. Okay, so I'm going to try and get rid of y so I can show you this whole process. Okay, get rid of y. Okay, so I'm going to take this first equation and this second equation, and I'm going to just add them together because these are already equal but opposite. So I'm going to add these two together. So I get x plus y plus z equals 1, and I get 2x minus y plus 2z equals negative 4. And if I add those together, that's the elimination method, I get 3x, those go away, plus 3z equals negative 3, right? So 1 minus 4 is negative 3. I'm going to write that down up here, okay? So 3x plus 3z equals negative 3, okay? And what you're going to see, because I got rid of y here, this equation doesn't work, okay? And again, I'll come back and show you the right way. But by happenstance, I got one like that. But I'm going to show you how to do it the right way, okay? I'm going to call this equation 4, okay? Equation 4. And what you're going to find out is with a system of 3 equations, you'll always end up with 6. And it's going to be 3, 2, 1, okay? With a system of 4 equations, you're going to end up with 4, 3, 2, 1, okay? With a system of 5 equations, you'll end up with 5, 4, 3, 2, 1. Okay, if you follow this method. But again, let's stick with 3. 3-dimensional problems are the most common. It's pretty rare to get up into 4 and 5 in most of your undergraduate classes. So, cool. Now I need to get rid of y again. I need another equation that looks like this. So I'm going to take equation 1 and equation 3. Okay, equation 1 and equation 3. Okay, and I need to get rid of y. So I'm going to multiply this one by negative 3 so that the y's will go away. So I get negative 3x minus 3y minus 3z equals negative 3. And then I take the bottom equation, 5x plus 3y minus z equals 25. And we see that those go away, right? Okay, and you see that those go away. I'll actually show you what I'm working on, right? I'm not used to teaching with a camera, so I struggle with it sometimes. Bear with me. All right, so these go away. What do we get, right? We'll add those. You get 2x. Add those, you get minus 4z. Add those, you get 22. Okay? That is equation number 5, and we're going to put it up at the top. So I'm going to go back up here, right? Boom. And write that equation down. 2x minus 4z equals 22. For this method to work, you have to have the same variables in these equations, okay? If you have an x and a y and an x and a z, this whole back substitution thing doesn't work. Now, you notice I crossed this out earlier. I crossed this out because I have x and z, x and z. This guy can only have one variable, and it has to be one of these two variables. It has to be either x or z. How do I get an equation with one variable? Well, I'm actually going to take these two equations, number 4 and number 5, and I'm going to get rid of one of these variables. Which one? It doesn't matter. Any one you want, okay? For the sake of my case, because this is positive and this is negative, I'm going to go ahead and get rid of z because it makes my life easier. So I'm going to take equation 4 and I'm going to multiply it by 4. What do I get? I get 12x plus 12z equals negative 12. And then I'm going to multiply this equation, number 5, by 3. Right? So 2 times 3 is 6, and 4 times 3 better be negative 12 because the whole point was to get rid of z. And then 22 times 3 is 66. And we're going to add those together. Again, this is the elimination method. 12 and 6 make 18x. These go away, hopefully. That's the point. And then 66 minus 12 is 54. Okay? Cool. And I'm going to write that down up here. Okay, so this is 18x equals 54. And that's equation number 6. Now, here's the linchpin of all of this. You work out to get 3 of these with 3 variables, 2 of these with 2 variables, 1 of these with 1 variable. And if you're doing something really complicated with this, it is a really easy system, because if you have an equation, a system with 3 variables, you need 3 with 3 variables, 2 with 2 variables, and 1 with 1 variable. If this original equation had 4 variables, you would need 4 equations with 4 variables, 3 equations with 3 variables, 2 equations with 2 variables. It's pretty easy to keep up with if you follow me. Okay, now, here's the linchpin. I need to make this a triangular system. Now, obviously, I have to use this equation, okay? So I'm going to write that down. I'm going to come down here. Let me move my paper a little bit so we can see everything. And I'm going to squeeze in right here these 3 lines at the very, very, very bottom, okay? Squeeze all this in if I can. And I'm going to say, okay, boom, 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 these 3 lines. And I'm going to put on this bottom line 18x equals 54, okay? Now, 1 variable. The next one up has to have 2. That's going to make it a triangular system. Guys, pick one of these. It does not matter which one you pick. Okay? I could pick number 4. You could pick number 5. It doesn't matter. Pick one of these. Now, I hear you through the camera. If I only have to pick one of these, why did I make 2 of them? Well, you have to have 2 of them to come up with this guy. That's the only reason. But you only need one of these to make a triangular system. So pick one. I'm going to pick 2x minus 4z. Okay? So 2x minus 4z equals 22. Cool. Okay? Now, last but not least, you need one equation with 3 variables. It doesn't matter which one. Pick one. Okay, well, I'm going to pick the top one. Why? Because it looks the simplest to me. No other reason. You could absolutely pick equation 2 or equation 3. Doesn't matter. But I'm going to pick equation 1, x plus y. So x plus y plus z equals 1. Okay, cool. Now, let's come down here. We've got our system. Your system can be different from mine. It doesn't matter. Solve by back substitution. So this one's pretty easy. You're going to divide both sides by 18. Okay, cool. Well, 18 times 3 is going to give me 54. So x equals 3. That's pretty easy. Cool. Now I'm going to plug in here. Plug in 3. Well, 2 times 3 is 6. subtract 6 from both sides, you get something like 4, negative 4z equals, subtract 6 from that, you get like 16, right? Cool. Solve that. What do you get? You get z equals negative 4. Cool. All right. Last one. Take this top equation here, right? We know x is 3. We know z is minus 4. So we get something like 3 plus y minus 4 equals 1. Okay. Well, you add those together, you get minus 1. Add it to the other side, and you get y equals 2. Okay. And you can do the intermediate work and see that it works. And then, of course, if you're in a math class, you have to put your answer as a point. And so we're going to go in alphabetical order, x, y, z. Don't go in the order you solved them on your paper, right? So x, comma, y, comma, z. And that's our final answer. Cool. And you can plug this into all of your original equations, and you'll see that it does, in fact, work. You can check your answers. So I want to do one more, okay? Not a triangular system, and we're going to make it a triangular system in an effort to solve this, okay? And again, I'm going to label these 1, 2, and 3 just for references. And I need equation 4, equation 5, and equation 6. And this has to have, right, so this has 3 variables, right? This has 3 variables. This has to have 2 variables. And this one has to have 1 variable, okay? Doesn't matter which one. So you can say, well, I want to get rid of z, or I want to get rid of y, or I want to get rid of x. It doesn't matter. It absolutely doesn't matter. So in this case, I'm just going to, for fun, I'm going to get rid of x, okay? I'm going to get rid of x. So here goes. I'm going to take equation 1 and 2, and I'm going to take this second equation here, and I'm going to multiply it by negative 2. And that way these will be equal but opposite. So I get 2x plus y minus 2z equals 3. If I multiply this one by negative 2, I get negative 2x. And then multiply that by negative 2 gives me plus 6y. Multiply that by negative 2 gives me negative 2z. And then multiply that by negative 2 gives me negative 28. Add these together. These go away. I get 7y minus 4z equals negative 25. Okay, I'm going to go write that up here. That's equation 4. 7y minus 4z equals negative 25. Now, make sure you understand this. If I got rid of x for equation 4, I have to get rid of the x for equation 5. I do not have a choice. So here goes. I'm going to take equation 1. I could do 1 and 3, because this was 1 and 2. I could do 1 and 3, or I could do 2 and 3. Okay, I just can't do 1 and 2 again. I have to pick another combination. So I'm going to do equations 2 and 3. Again, because this is a 1, it's really, really easy to cancel stuff out. So I'm going to take equation 3 and copy it down. Not going to change anything about equation 3. Okay, so copy that down. And again, I'm a little off camera. I'll move it. Okay. So I'm going to take equation 2, and I'm going to multiply by negative 5. That's going to give me an equal but opposite here. So that'll be negative 5x. And it's funny because all this multiplication, tends to be where you screw up. So, be careful. So negative 3 times negative 5 is positive 15y. And then that's going to be pretty easy. That's going to be negative 5z. And then 14 times 5 would be 70. So this will be negative 70, right? Because it's times negative 5. Cool. We're going to add these together. Again, that's the elimination method, right? And we're going to get negative 65 over here, okay? And we're going to get negative 8z, and we're going to get 19y. And these are going to go away. And I'm going to write that up here. So this will be 19y minus 8z equals negative 65. Cool. Now, I need to take these two and get rid of a variable. And I can't stress this enough. It doesn't matter which one. You could get rid of y. I could get rid of z. We will get the same answer unless one of us makes an arithmetic mistake. Okay? So again, I look at these numbers. 7 and 19 aren't pretty. 8 and 4 are. So I'm going to get rid of z because I know the math is simpler. So what do I need to do? I'm going to copy equation 5. So 19y minus 8z equals negative 65. Just copy that. I'm going to take this top equation, number 4, and I'm going to multiply by negative 2. Okay? That's going to make this positive 8, which is going to cancel it out. Okay? So this will be plus 8z, right? So times negative 2. Multiply that by negative 2. That's going to give me positive 50, right? And multiply that by negative 2. It's going to give me negative 14y. Put those together. What do we get? Well, I get negative 15. Those go away. And that's going to give me what? 5y. Cool. That's equation 6. 5y equals negative 15. Boom. Now, we need to make a triangular system. And I'm going to say this until I'm blue in the face. It doesn't matter which equations you pick. You have to pick one from this list, you have to pick one from this list, and you have to pick one from this list. It doesn't matter which one. So obviously you have to use 5y equals negative 15. And conversely, the question I get a lot is, instead of putting 5y equals negative 15, could I put y equals negative 3? Sure. I'm just really lazy and don't want to do it yet. Honestly. So I just copy that. But if you want to go ahead and solve it, you can. Cool. Here, pick one. Doesn't matter which one. You could pick equation 4. You could pick equation 5. I'm going to pick equation 4. Why? The numbers are smaller. No other reason. Okay? So I'm going to say 7y minus 4z equals negative 25. Okay? So picked one of those. Picked one of those. Now pick one of these. Again, which one? Doesn't matter which one. Because my first example, I picked number 1, I'm going to pick a different one this time. I'm going to pick number 3. You can pick number 1, you'll get the same answer as me. That's what makes this so cool. So copy equation 3 here. I'm going to put 5x plus 4y minus 3z equals 5. Now, this one's pretty easy to solve. It gives me y equals negative 3. Okay? I'm going to plug that into this equation. So, well, 7 times 3 is 21. So 7 times negative 3 will be negative 21 minus 4z equals negative 25. Okay? Now, if I add 21 to both sides, I'm going to get negative 4z equals negative 4. Okay? So if I add 21 to both sides, I get this. Okay, well, divide by negative 4, you get z equals 1. Okay? And then last but not least, we're going to solve this top equation. So we're going to take this top equation. I'm just going to kind of go over here somewhere. Lots of space over here. And I'm going to say, okay, 5x plus 4y minus 3z equals 5. So I'm going to take that equation and plug in my 1 and my minus 3. Okay, so that gives me, right, that's going to be minus 12. And that's going to be minus 3. So that's going to be a total of minus 15. 12 and 3 is 15. Cool. Add 15 to both sides. I get 5x equals 20. Divide by 4, you get x, divide by 5, and you get x equals 4. I'm jumping ahead of myself here. Okay? Right? So 5 goes into 24 times. Boom, boom, boom. There's your answer. Okay? There's your answer. Now what? Well, just write it as a point. Right? So x, comma, y, comma, z. Systems of equations with 3 variables. So if you have questions, leave them in the comments. Let me know, and I'll do my best to answer them. Or if you have video ideas, something you want to see a video of, let me know, and I'll do it. Thanks, guys.